Thank you, Dr. Watson. Thank you in particular for setting the standard for UAB to be an institution that serves our country in this region and our patients. That's been your commitment since you were dean and now as president. For those who are not completely familiar with UAB, we are an institution tremendously driven and guided by service and a compelling, really, vision and mission to serve the people of this part of America, particularly the state of Alabama. The collaboration of our hospital leaders, our departments, and particularly this case, our surgical team and our transplant institute really demonstrate the spirit of our institution. For those who don't, UAB is the 8th largest hospital in our country and the 4th largest public hospital in our country. It's one of the top 2% of all universities in NIH funding, and also one of the top 10 public academic medical centers in NIH funding. It's the largest employer in our state and one of the largest in the region, employing over 26,000 employees. And by Forbes, nationally was ranked America's best large employer. Specifically, our transplant program has a phenomenal history that many in this audience have been a part of. Committed at its early stages to serve all of our citizens with an altruistic behavior by those donating and those in need of a kidney transplant. Dr. Arnold Deham was recruited here by Jim Kirkland in the late 60s after training in the lab of Dr. Joe Murray, who was the last surgeon to win the Nobel Prize for kidney transplantation. Dr. Deham brought that expertise here early on, created one of the first programs in the country with the commitment to transplant all of our citizens in this area. UAB sits in one of the spots where the greatest burden of disease for chronic disease exists in our country and is committed to serving that population. Under Dr. Deham's leadership, the program grew to be one of the largest, if not the largest in its early time in the country for transplantation. In fact, over the last 30 years, UAB has done the 2nd most transplants of any academic medical center in the world. And in fact, because of our commitment to serve our entire populations, it has done more transplants in African Americans than any hospital or institution in the world. This next step, obviously, is one where we continually want to deal with the lack of opportunities for so many people who have chronic renal disease. And what you will hear today from Dr. Jamie Locke is a long-standing effort by many who've been a part of this community to build an opportunity for having a cure to potentially be offered to all of those who suffer from renal disease. You'll hear about the numbers, and I won't share that, but you'll also understand that the long-term passion that's been built by execution and commitment of this team who's here today, and the Parsons family, who in their spirit of their loved one who's gone on, wanted to be a part of serving his community, was able to do that in a phenomenal way. So to that end, I want to bring Dr. Jamie Locke to the podium, who's she's the chair, she's the chief of the Comprehensive Transplant Institute. She's also the division chief of the Division of Transplantation, and she holds the Mark Dearhor Chair in surgery. Jamie?
Thank you, Dr. Vickers. Good morning, everybody. What an absolutely wonderful day. It's really my honor to be here and to have the opportunity to represent not only my colleagues and the tremendous achievements that we've made in medicine and science today, but also to represent the Parsons family and the tremendous commitment that they made to honor Mr. Parsons' legacy. We're also here today, and I think that what we'll be sharing with you, part of what makes it such a wonderful day, is the hope that this provides for the many patients in kidney failure who do not have access to a kidney transplant. So let me start by giving you a little bit of perspective. So if you take a look, there's a huge organ shortage. If you look at the gap between demand and supply, you can see that roughly between 80 and 100,000 Americans are on the waiting list for a kidney transplant, and we perform fewer than 25,000 per year. And if you look at the bar graphs at the bottom of the figure, you can see that the transplant curve has really remained flat for 20 years, despite multiple efforts to increase organ donation. It's important to note that 40% of waitlisted patients will be dead within 5 years. So if they don't receive a kidney, many of these patients will die. If we back this up further, you'll note that the problem's even larger than what this figure shows. There are 37 million Americans that have chronic kidney disease, many of whom will progress and go on to develop kidney failure. And there are 800,000 Americans who are defined as having kidney failure, 600,000 of whom are on dialysis. And yet fewer than 100,000 are even listed for a transplant. And we perform fewer than 25,000 kidney transplants per year. Why is that significant? Because kidney failure will be a death sentence. Dialysis is not the answer. And we know that kidney transplantation is the cure for kidney failure. It is the gold standard, and yet we do not have enough organs to go around. The organ shortage is a refractory, severe, and impactful problem. It is an absolute crisis, and we need a radical solution. Not surprisingly, the federal government acknowledged this as well. Under the last administration, an executive order was issued on kidney disease, and an emphasis was placed on identifying artificial sources of organs. And you could argue what we're here to talk about today sort of meets that criteria. And so what are we talking about? We're talking about xenotransplantation, or the development of an additional source of organs for the purposes of transplanting individuals with kidney failure. And how do we do that? Well, we need to genetically modify or humanize a source animal kidney, in this case, a pig kidney. And some of the things that we've had to overcome are incompatibility, worries about viral transmission of diseases that pigs have that could go to humans. And through genetic engineering, we've been able to overcome these feats. And it was really with the introduction of the CRISPR-Cas9 system that has really sort of revolutionized genetic engineering that has been around for a while. But that particular tool has increased the precision and the rapidity with which genetic engineering can occur. And it's important to note that 2 women won the Nobel Prize in 2020 for chemistry for this discovery. It has propelled the field of xenotransplantation and other fields, and it's allowed us to do high throughput engineering to enhance human compatibility of pig organs, as well as overcome some of the concerns related to viral transmission. So with that, the field of xenotransplantation has further exploded, and these genetically modified pig kidneys have been tested in non-human primates, which are thought to closely recapitulate human biology. On the right-hand side of the screen is a genetically modified pig kidney that has been implanted into a baboon, and you can see that it's beautiful in pink. This baboon had both of its native kidneys removed, and this kidney survived and helped the baboon survive after transplant. So while we've genetically engineered these pig kidneys to look less foreign to the human immune system, and we've tested them in the non-human primate model, the non-human primate model is not perfect. So non-human primates are immunologically different enough that we can't answer certain safety and feasibility questions in this model. For example, the immunosuppression used is quite different than what we use in human beings, and there was no cross-match to determine tissue compatibility, and we didn't know if these pig kidneys would be compatible in human beings. So we needed a new model. And approximately 2 years ago, we began to explore the possibility of leveraging human brain death as a preclinical human model to study the human condition. We began with an external ethics review. We engaged our internal review board as well as others across campus. We partnered with our organ procurement organization, Legacy of Hope, to help us identify individuals who had decided to be organ donors upon their death for both the purposes of transplantation and research, with the hope that we might be able to enroll a participant in this research study. And the design advantages of this preclinical human model is that we could test some of these key elements that we could not understand or learn from in an animal model. And we could do this without harming a living person. It allowed us to test our engineering, test our immunosuppression, and test the development of a novel flow crossmatch to predict tissue compatibility. So as I mentioned, to do this has been a 2-year journey to get here. It was important to us to have an external ethics review. It was also important to us to have our internal review board involved. And the internal review board at institutions is responsible and oversees research in humans. Because this was a brain-dead model, in theory, this is not considered human subjects research. But we wanted to closely recapitulate what this would be like for a phase 1 clinical trial in living persons. And it was also important to us to engage experts in informed consent to ensure that we had an informed consent process that could really explain what was involved to the family so that they could make a truly informed and autonomous decision about having their loved one participate in this study. We also did this in conjunction with IACUC, which is the animal version of an IRB that oversees our pathogen-free facility. It's important to note that the Xenotransplant Program at UAB began in 2016, in which we made a concerted commitment to figure out how we could identify and solve the organ shortage by creating an alternative source of organs. And we think that we can do this the fastest and the quickest through xenotransplantation. As part of this, a pathogen-free facility was both developed and implemented, and we have members of that facility here, and a huge shout out to them. It's over the last 5 years, what they have accomplished is remarkable, and when we've been able to rear and breed pigs in a pathogen-free facility to ensure that we don't have viral transmission and to meet rigorous standards that federal regulators might have. So we propose to do all of this, and we propose to transplant for the first time into a human brain-dead recipient sometime between April of last year and April of this year. And we successfully accomplished that somewhere in the middle. And we performed this on September 30th of last year. And we performed the first clinical grade porcine kidney xenotransplant into a human being. On the left-hand side of the screen is a screenshot of the manuscript. We elected specifically not to come out with this until we had the opportunity to have our science evaluated by other scientists in the community and have this done in a peer-reviewed fashion. That is the press release that you see there on the screen. So what did we accomplish? The first is a clinical grade 10 gene edited pig to human transplant. And what do we mean when we say clinical grade? We mean that the pig came from a pathogen-free facility. That type of facility is going to be necessary for us to be able to offer this more to one individual and outside something like an emergency authorization. And so it was very important for us to be able to test operationally our ability to do this, to have an operating suite within the pathogen-free facility that allowed for the procurement of the pig kidneys in the most sterile of conditions, to be able to package those kidneys for transport just like we do in human-to-human transplantation, to be able to transport them to UAB Hospital and perform the transplant. So here are two members of our team transporting the pig kidneys. You can see Dr. Arandi is holding a styrofoam cooler. That is where the pig kidneys were contained. This is similar to the practice we have in human-to-human allotransplantation. In this picture, you can see the pig kidney, and this is prior to restoring blood flow. You can see it's pale. We then transplanted and completed our vascular connections and restored blood flow to the kidney. You can see in the next picture that it's beautiful in pink. That's a Doppler probe listening to Doppler signals throughout the kidney. And within 23 minutes of restoring the recipient's blood flow to the pig kidney, it began to make urine. This is a remarkable accomplishment. It tested from start to finish how we might recapitulate this in a living person, testing both key safety and feasibility measures. One of the key things that needed to be done was the development of a flow cross-match that was specific for pig to human transplant. Flow cross matches are used in human-to-human transplantation to ensure that there is tissue compatibility, meaning that when we transplant that kidney, that it will not immediately hyperacutely reject, meaning that it would reject right before our eyes and have to be explanted. In fact, this is considered such a key element of transplantation that federal regulators require cross-match testing to be completed prior to transplantation in the context of human-to-human transplant. Prior to our study, no such test existed, and I want to give tremendous credit to Dr. Hopfeld and her team in our histocompatibility laboratory who developed this novel flow crossmatch that was specific for pig to human transplant. They were able to predict a priori, meaning prior to transplant, that there would be a negative crossmatch, meaning there would not be hyperacute rejection. The only way to test that was to do the transplant and show that after reperfusion, we had a beautiful pink kidney, not one that turned black from hyperacute rejection. This cross-match only exists here at UAB, and it will need to be leveraged for the widespread adoption and use in living people for the purposes of pig-to-human transplantation. As I mentioned, we also test the process from start to finish. We also were able to assess the recipient's blood for the presence of pig viruses, and we were able to ensure that we did not transmit any porcine endogenous retroviruses, again, confirming our ability to maintain a pathogen-free facility and to have the safe procurement and transplantation of pig kidneys into humans. We also were able to demonstrate that we did not observe any pig cells circulating in the recipient's blood. Another important milestone, we could be reassured that we were not going to see graft versus host disease, which can in fact happen after transplantation, even in human-to-human transplant. And I think importantly, beyond xenotransplantation, this study really established brain death as a preclinical human model to study the human condition. And I just cannot thank the Parsons family enough for honoring Mr. Parsons' decision to be an organ donor upon his death. And he was agreed to be an organ donor both for the purposes of transplantation as well as research. It was important to him and to his family to honor his legacy by being able to give back to the community around him and to help people he has never met. What Mr. Parsons did and the decision that his family honored has not only helped patients who have kidney failure one day be able to achieve a transplant where we eliminate the organ shortage crisis. There's no longer a wait. When you need a kidney, we have one. But beyond that, this model, I believe, will be able to be leveraged to study all sorts of human conditions in which animal models are not appropriate. And the Parsons family and Mr. Parsons deserve all of the credit. And we propose heretofore that this model be known as the Parsons model. And with that, I do want to thank the team both at UAB Medicine, the Legacy of Hope, as well as the UAB Heersink School of Medicine for all the hard work. This picture represents the individuals that were involved in the operating room, but it doesn't do justice to all the individuals that were involved in this process, many of whom have joined us today and are in this room with me as a part of this press conference. To each of you, there are too many to name, but we say thank you. And on behalf of our patients, we say thank you. Today, we just gave hope to the hundreds of thousands of Americans who suffer from kidney failure, who don't have access to a life-saving kidney transplant. To the Parsons family, thank you. We wouldn't be here without you. And for all of our patients, and on behalf of all of them, we say thank you. You have saved countless lives moving forward, and I hope that gives you solace in your grief. And I hope you know that we are truly honored to be able to continue your father's legacy in this manner. So thank you very much, and we will be answering questions at the end. At this time, I would like to introduce the Chief Scientific Officer for Revivicore, Dr. David Ayers.
Dr. Ayers, we cannot hear you because you're on mute. So we're going to ask you to unmute now and start over, please.
Thanks, Dr. Locke. This is indeed an exciting day. All of us at Revivicore, along with our parent company, United Therapeutics, are in awe of the historic achievements at the University of Alabama, Birmingham, with our investigational 10-gene U-kidney. The U-kidney may turn out to be a life-saving solution for thousands of people on dialysis, subject to successful completion of future clinical trials and achievement of full FDA approval. This preclinical study and resulting peer-reviewed publication will assist in the further development of xenotransplantation, Revivicore and United Therapeutics are committed to continuing our development efforts with the goal of FDA approval of our xeno organs like UKidney to address the critical unmet need for transplantable organs in the United States. We carefully selected and tested the 10 gene edits reflected in the UKidney to facilitate compatibility with the human immune system. Building on the GalSafe gene modification, this is the first FDA-approved genetic modification in a mammal. The donor pig had 10 genetic modifications, including the knockout of 4 pig genes and the addition of 6 human genes. These modifications may make the pig organs more tolerable for human transplant recipients. Additionally, thanks. We stress that this historic achievement is an experimental step, part of the process that we hope will lead to securing approval for use in patients. The UKidney is not approved by the FDA, and we, along with our academic collaborators, will continue to pursue our development and regulatory path towards obtaining FDA approval. The recent procedures by UAB and those reported by Revivicore and other United Therapeutics collaborators over the past few months represent the culmination of 2 decades of work by my team, starting with the first cloning of pigs to optimizing various gene editing constructs and building state-of-the-art farm facilities to house these incredible animals. We look forward to continued engagement with FDA in the coming years to bring engineered organs like UKidney to patients in need. So turn it back to Jamie. Thank you.
Dr. Locke, we're having a few technical difficulties. If you can hold for just 1 second, please. This microphone is muted. If the production team can unmute. Okay, Dr. Locke. Okay, Dr. Locke. Dr. Locke. Dr. Locke. Dr. Locke. Dr. Dr. Locke, we're going to have you hold for one more moment. I apologize again. We've got to figure out what's going on with our sound quickly. Just, can you hold for just 1 second, please?
Good morning. Can you hear me? Okay. Again, I just want to say it is my distinct privilege and honor this morning to introduce Ms. O'Hara, who is the ex-wife of Mr. Parsons, but importantly, his longtime partner, as they describe it, rearing their children, and importantly, being a critical component of making this decision and helping to honor Mr. Parsons' legacy. So Ms. O'Hara, thank you for being here, and I'll turn the podium over to you.
Good morning. Thank you for being here today to learn about what we believe is a remarkable scientific achievement and to learn about and celebrate the life of a father, a son, a friend, and a servant to others, Jim Parsons. A man who truly lived to help others in both life and death, as evidence of why we are all here today. I'd like to share a bit about Jim so people will know what type of man he was. Jim was fun. He lived life to the fullest, ready for the next great adventure. He lived for his family, namely his children. He lived for curvy roads on two wheels and tight woods with muddy trails. By day, he was a carpenter. He could transform your kitchen or give you the closet of your dreams. But at the very core of Jim Parsons was his love of riding motorcycles. He started at the age of 14 and developed into a great dirt bike rider, winning countless first place trophies. This is ultimately what took his life. But before he died, just 2 weeks before, he took his sons and my brother, his best friend Ryan, on a trip of a lifetime to ride dirt bikes in the mountains of Colorado. He took them to all of the places he'd always dreamed of showing them. And it was when they got to the top of American Flag Mountain that he confided to the boys that this was where he wanted his ashes spread. Just a couple of weeks later, a few days after his 57th birthday, Jim was racing with our son, David, and my brother, Ryan, like he had done hundreds of times before. He knew the potential consequences of racing. Every racer does. But that day, he hit a tree the wrong way and succumbed to those consequences. He was resuscitated and life-flighted to a hospital in Montgomery, but we were quickly informed that he was brain dead. We had time as a family to grieve and to say our goodbyes, but we also knew that Jim had more to give. He and I had often talked about being organ donors. His parents were leaving their bodies to science, and we agreed that organ donation was what we wanted to do upon our death. So when we were approached by Legacy of Hope and Dr. Locke about this study and what she hoped it would ultimately accomplish, we had no doubt as a family that this is what Jim would have wanted, to potentially help hundreds of thousands of others. If he knew that participating in this study could potentially give the nearly 100,000 people in the United States waiting for a kidney transplant the chance at living a healthy life, he wouldn't have had a moment's hesitation. He would be all in. That was who Jim was. Our greatest hope is that this study, which is now called the Parsons Model, will ultimately bring new life to hundreds of thousands of people in the United States and around the world in need of a kidney transplant. We also want to bring awareness to the need for organ donation and share light on how big of a crisis organ shortage is. Our daughter, Allie, said recently that losing her dad is the hardest thing that she's ever been through. It still is, and we are reminded of that every day. But we know that Jim is so proud that we are gathered here today and that we have had the opportunity to share his story and his legacy. More importantly, we hope our story inspires other families to consider organ donation and sharing the gift of life forward as Jim did. On behalf of Allie, David, Cole, and our entire family, I want to thank Legacy of Hope and UAB, especially Alan Spriggs and Dr. Jamie Locke. Throughout this journey, they have been Jim's advocate. And we thank you all from the bottom of our hearts. And all of you out here, it's just overwhelming to see the number of people that it took to put all this together. We all look forward to the day when the first pig to human kidney transplant takes place in a patient that can go on to live a long and healthy life. We're forever honored that Jim's gift has an opportunity to give those in need a chance at life. Thank you.
Thank you, Julie. We're going to ask Dr. Locke to join and Dr. Vickers to join Julie up here for questions. Media, if you have questions, please, Savannah Copeland from our office will be calling on you. Just raise your hand in the Zoom function or drop a question in the chat and we'll get started.
Yes, as Tyler mentioned, if you have a question, please use the raise hand function or drop your question in the chat and we will ask on your behalf. Please state your name and your outlet, and if you have a question directed for a specific speaker. In an effort to not cause any further issues with audio, any questions directed for David with Revivicore will be arranged by phone after the press conference. So with that, we will open. The first question is from Francis Sellers with the Washington Post. I think Dr. Locke, this will be for you. Can you comment more about how this is a first? Is it because the research was peer-reviewed and published? What specifically sets this research apart from others in the news recently?
Thank you for that question. I think there are several notable firsts that make this the first. The first thing is that this was a clinical grade 10 gene edited pig that was transplanted inside a human recipient in the same fashion that we perform human to human allotransplantation. When I say clinical grade, it means that the pig kidney came from a pathogen-free facility. And so that makes it a first as well. In addition to that, it's the first time that a pig to human specific flow crossmatch has been developed and then actually validated. So we predicted with a negative crossmatch that we would not see hyperacute rejection, but the only way to validate the crossmatch was to actually perform the transplant. And as you could see from the pictures, the kidney was beautiful and pink and did not hyperacutely reject. We also were able for the first to demonstrate that there was no transmission of porcine endogenous retroviruses in the human recipient. There was also no evidence of chimerism, meaning we did not detect pig cells circulating in the human recipient's blood. And yes, in fact, this is peer reviewed, which also makes it a first, as all of these data have been critically reviewed by other scientists and experts in the field, confirming our findings and now available online via the American Journal of Transplantation. The other thing that this did is really test operationally our ability to do this from beginning to end. So you have to visualize the concept of having a pathogen-free facility with an operating room that meets standards that you would see in a human hospital, JACO type requirements, where these pig organs could be harvested in a sterile fashion, packaged, transported to a hospital, and successfully transplanted into a human brain dead recipient. That really tested key operational points that are going to be necessary if we want to extend this beyond an individual patient and be able to offer this to the masses. And I think each of these firsts that I described are going to be key data elements that federal regulators are going to want to see and understand that could not be answered in the context of a non-human primate model. So we're very excited about this because we genuinely believe this is going to be it's going to take to help us advance and move the field forward. Thank you.
Thank you. Ilya Kolmanovsky, you can unmute and ask your question. Please state your affiliation.
Hello, this is a Naked Mole Red podcast, and this one is probably for Dr. Vickers. Could you please give us some timeline of your collaboration with Revivicore? Who initiated it? Who reached out to whom? How did it start and when? And did that FDA approval of alpha-gal safe pig December last year play any role into that timeline?
So as Dr. Ayers mentioned, we've had a long-standing relationship with United Therapeutics. Their CEO, Martine Rothblatt, has been a tremendous collaborator for many institutions in this field, but particularly with UAB over the last really 3 to 4 years. That partnership really has driven the multiple both studies, both in research and clinical, for us to move to this level. So I think as you heard initially, really our 4-year culmination of work with us as one of the main institutions. The concept of this has been around some time, but I have to say that Dr. Locke was one of the first to propose that this could really give us information that could lead the way to a clinical trial for transplantation. And the evolution of the editing of the pigs and the genes and CRISPR-Cas obviously had a huge impact on creating the opportunity where these organs would not be rejected. I didn't quite understand your question around December.
Well, there was this milestone. There was this milestone December last year when FDA by the host now. Sorry. Let me repeat it. December last year, FDA has approved gall-safe pigs by Revivicore. I guess to be eaten, but it was in small print for therapeutics as well. I was wondering if this was a milestone for, to move forward with xenotransplant. But was this a milestone for you?
I think certainly the approval of the gall-safe pig, which again was done for the purposes of food consumption, is certainly a milestone, certainly for Revivicore, but also for the broader field of xenotransplantation, because anytime we have the opportunity to interact with the FDA, be able to demonstrate data and be able to gain approval, I think that does move the field forward. We're going to need the FDA's approval of these genetically edited pig kidneys in order to move this into living persons. So I think that certainly was a nice step along a very long process that's going to require further interactions, but certainly I would consider that a milestone, yes.
Thank you.
And for the future, sorry. I was
sorry,
wondering
we've got another question. Sorry, feel free to keep going.
Oh, thanks. I was wondering what's the roadmap for the future? How long until the actual xenotransplant in human, and what are the main milestones to be achieved?
Thank you for that question. Our hope is to continue to move this process along. I think the data that has been collected from this particular study is going to be key as we begin to have discussions with the FDA about obtaining an IND, which is something that we would like to do. We also have been working with our internal review board about what a phase 1 clinical trial would look like. And certainly having IND approval from the FDA will be a necessary component to receive approval from our IRB to move forward with a phase 1 clinical trial. We are very hopeful that we are able to get an investigator-initiated IND at some point this year, and we are very hopeful that we would be able to implement a phase 1 clinical trial later this year. We do have a herd of pigs that will be ready in the coming months in terms of appropriate size that are 10 gene edited for us to begin the phase 1 clinical trial. So my hope is that sometime later this calendar year.
Thank you. Julie, the next question is going to be for you. A few people are asking just a little bit more about what that process of making this decision was like for your family. And through this, how do you and your family want to memorialize Jim?
So, as I said, we were going to donate Jim's organs. And about an hour and a half before his surgery to harvest all of his organs, I got a call from Legacy of Hope. And Dr. Locke got on the phone, and my daughter and I were in the car, and she put the whole thing out there, and what was going to happen if we agreed. And my daughter and I looked at each other, and we were just without a doubt, we knew that that's the way we wanted to go with Jim. So we halted his surgery, and the UAB arranged to have him transported up here from Montgomery, which was where he had been life flighted to. And then the second part of your question was?
How do you hope that this process memorializes him moving forward in his memory?
We are just thrilled that they've decided to call this the Parsons model. And I think he would be very proud also. He would probably be saying, stop talking about me so much right now. Let's get the focus on all of you people in the room here and off of him. But we're very proud to memorialize him this way.
Thank you. Dr. Locke, the next question will be for you. You touched on this in your presentation, but a few people are just curious. Can you talk a little bit more about the crisis of kidneys being in need and what you hope this means for the future of those patients who are on a list?
Absolutely. So the thing about kidney failure is I think many people sort of say, well, we've got dialysis, we're good. But dialysis is awful. It comes with a significant mortality. As I mentioned, 40% of the patients on the waiting list, if they don't get an offer and actually get transplanted, will die in 5 years. And so dialysis is not the answer. Since Joseph Murray performed the first successful kidney transplant, I believe in 1954, for which he won the Nobel Prize, we have known that kidney transplantation, in fact, is the gold standard, and it is, in fact, the cure for end-stage kidney disease and kidney failure. And so imagine any other disease condition in which I, as a physician, along with many of my colleagues in this room, I've got a cure. I know exactly what the cure is, and I don't actually have enough to go around. And now imagine every week, and we have evaluation clinic at UAB 5 days a week. And we see patients every single day, Monday through Friday, and we evaluate them for waitlisting. And every day, myself or one of my colleagues has to tell someone that either they're not a candidate, or if they are a candidate, they're going to have a really long wait. And depending on their blood group, the wait could be upwards of 10 years. And many of these individuals are going to die before we ever get them a kidney. We have tried so many things in this country to increase organs, the availability of organs, and a huge shout out to our organ procurement organization, who's one of the best in the country at doing it. Their conversion rate is fantastic, but yet the need still far exceeds our supply. So if you look right now in the US, there are a little under 100,000 individuals waiting for a kidney transplant, and this year we'll perform fewer than 25,000. And if you back it up further, there are another 600,000 Americans that actually have end-stage kidney disease that have yet to make it to a waiting list. And oh, by the way, there are 37 million Americans that have chronic kidney disease. Many of them don't even realize they have it, but will go on to progress and develop kidney failure and ultimately need a transplant. Again, they have a disease that we have a cure for, but we don't have enough. And we need a radical solution. We have to find an alternative organ source, and xenotransplantation, I believe, is the answer. And it is my great hope that certainly in the next 5 to 10 years, and if not by then, during my lifetime, that xenotransplantation becomes a reality, so that every patient that walks into our clinic that has this need, that my colleagues and I can give them their solution. And I think what we have done here today, I hope, if nothing else, in the immediate, provides hope to all of those individuals who are waiting, who are looking death in the eye and are hoping beyond all hope that they get that call for a transplant. I hope this gives them hope for a future where there will no longer be a wait.
Questions for you. When this procedure becomes possible, will UAB have to grow its infrastructure to make this work as well as it could?
We would love to have that problem. And as you've heard from Dr. Locke, the burden of disease for chronic renal disease is huge across our country. And as you heard me mention earlier, we sit in the epicenter of that, where the greatest burden exists. And we've been committed to serving the populations of this region throughout our entire history with what the latest science had to offer, as well as helping define that science. And so, yes, you can imagine that we would need a specific facility. We need newer, in part, more individuals to help drive it. But it's a graduated process. The phase 1 clinical trial has to be done first. We have to be clear about the right model for the pig to make this happen. And then we need to make sure we have the recipients who are the right ones to get the organs. And if we were to progress through that process, then we would love to be able to upscale and grow. And we have our leaders of our health system and our hospital here as well, who would love to take on the task of making that a reality for our surgeons, but our patients and our citizens.
Dr. Vickers, actually just another thing to ask you. Can you just speak a little bit more about what does this mean for UAB to be at the epicenter of this research?
You know, I go back to Dr. Watt's leadership, who's pushed us to really, at every level in our institution, particularly on our academic medical side, to really be a leader in the country and the world for the areas that we know that we can do that in. Transplantation is clearly one of them. You heard me list that unique history of beginning a transplant program, one of the earliest in the world. And albeit in Alabama, we did it and have grown it to be one of the biggest in the world. So it's just a reflection, as you've heard, that this did not occur overnight. This has been a long journey and commitment of our institution to actually be an outstanding academic medical center that any place in the country could be proud of, and provide the latest opportunity, whether it's cancer, cardiac, or transplantation in medical care, that would not only benefit citizens here, but would benefit people for all over the world. So it's a reflection of who we are and what we've wanted to actually demonstrate throughout our history.
Thank you. Dr. Locke, can you comment a little bit more? Are these bridge to transplant kidneys, or will these be usable long-term?
That's a great question. And I think one of the things and reasons why we need to be able to progress and move this into living humans. Our hope is that this will be destination therapy, meaning the patient receives the transplant and it survives the duration of that recipient's life. But we need to do the research to determine that. And that's why we need to be able to progress to a clinical trial in living persons. I do think it's important to note that the lifespan of a pig is about 30 years. So it is our great hope that we will be able to make use of that full lifespan such that a pig kidney could sustain a living person dialysis free for 30 years.
Thank you. Tyler, I think that's all for our questions.
All right, thank you everybody for being with us today. And again, to members of the media on the call, as a reminder of our institutions, University of Alabama at Birmingham on first reference and UAB on second. And you can also get the media kit at go.uab.edu/xenotransplantation. Thank you very much. We appreciate you being here.